Let's take a look at some standard application problems that you'll see in calculus. Okay, let's say given y equals, how about 3x cubed minus 7, what is the equation, okay? Equation tangent of line, so what is the equation of line? Tangent to curve when x equals 1. Okay, so this is basically a straight line application problem. It's kind of what we actually started with. But let's just analyze it in this given context. Okay, we have some curve, y equals 3x cubed minus 7, and we want to get the tangent line at a given point when x equals 1. So what's our general approach? Well, to get the tangent line to a curve, we need to take the derivative. Okay, so let's start with that. Let's take the derivative. So we get y prime equals, in this case we get 9x squared minus 7. Now, that gives us the tangent to this curve at every point. For this specific case, we want to know when x is 1. Okay, and so when x is 1, okay, y prime of 1 equals 9 minus 7, which is 2. So the slope at the point 1 is 2. So we've got the slope, we've got our x1, all we need is our y1, and we get that by going into the curve. So for y of 1, we get 3 times 1 is 3, I'll put it in here, 3 times 1 cubed minus 7, which is equal to negative 4. So now we have everything we need for the equation of the line. Recall the equation of the line, y minus y1 equals mx minus x1. And so we're plugging in for x1, y1, and m. So y minus y1 is negative 4, so that's a plus 4. M is what we got from the derivative, that's a 2. We're left with x minus 1 given to us in the problem, and this finishes this problem. You don't need y equals mx plus b form. You can leave it like that. Okay, next. Let's consider the following. Let's say a particle, okay, so a particle moves through time. So we'll just say with equation what? So it's got some equation that's showing how its distance is changing over time. And say, well, let's say s of t equals, and let's go with, we'll do t squared minus 6t plus 8. And then you'll have a series of questions that go with problems like this. And the questions might be like the following. One, we'll just take them one at a time. What is the velocity after 1 second? Okay, well what velocity is, it's the derivative of position. So what you need to do here is you need to take the derivative of your function, we say s prime of t equals, and I've got 2t minus 6, right? And so after 1 second, you just plug in 1. And so I put in a 1 here, and I get 2 times 1 minus 6, which will give me negative 4. So for velocity, what that means, the particle is going backwards at that time. Great. Number 2. When is the particle at rest? These are classic. When is particle at rest? Okay, so it's at rest when what? When the velocity is 0. So the idea is it goes back, it comes to a complete stop. Okay, it's not moving, the velocity is 0, and then it goes in the other direction. So what we can do is we can set s prime of t equal to 0. So we've got s prime of t, which equals 2t minus 6. We can set that equal to 0, and we can solve this easily for t equals 3. Okay, so it's at rest after 3 seconds. Okay, great. And then one more. You got all kinds of questions for these types of problems. Let's say, what is the acceleration? Okay. Okay, let's just say generally what's the acceleration? Well, the acceleration is the second derivative. It's the derivative of velocity. So we actually need s double prime of t. And then that's just simply 2. So it's moving, it's accelerating at 2 meters per second. It's got some initial kind of push backwards, and then it's gradually accelerating forward because the derivative of 2t is 2. Okay. And we'll do like one more physics one. Okay, so in this one, I'm going to give us a little diagram, and we're going to take like a spring. Let this be or 0. And the spring is here, okay? And the spring is stretched down to say -3. Oops, too many negatives. So -3. So we go 0. Okay. So what's the setup here? A spring is pulled down 3 units. And sometimes you're given an equation. So the equation, and I'll just write it up here, will be the following. It's going to be s of t equals, now what would this be? So a spring is going to oscillate, it's going to go up and down. And so if you pull it down all the way to -3, okay, that's the max, and you get the max when the cosine is 0. So it's going to be -3 cosine of t. Okay, and so what we're going to do is analyze like the motion of the spring. Okay, so it's the question is what's the velocity of the spring at any given time? Okay, so maybe I'll write that down. So this is our setup up here, and then we say what's velocity of spring? So what's the velocity of spring at any given time? And I think this is kind of a nice question because I think it kind of illustrates the power of calculus, right? Calculus delivers this, okay? If you can have an equation of motion, which -3 cosine of t will work here, then you get the velocity at any given time. And furthermore, at this point, it should not be difficult, right? It's simply s prime of t. That's what the velocity is. So we could write v equals s prime of t. And what's that? Well, the derivative of cosine is negative sine, so we get a +3. So it's 3 sine of t. Very cool, very straightforward, and we can even add, this is similar to the particle problem, you know, you can ask, well, how often does the spring stop, right? You know, what's its velocity at time pi/4, okay? Or pi/4 seconds. And, you know, maybe we'll just quickly do those. So, okay, so this would be like our first question, you know, 1, and then 2, when is it at rest? Well, you've got to solve v, which equals 3 sine of t, equal to 0. And this is going to work whenever t equals what? T equals, well, it's not just 0, right? Certainly 0 gives you 0. For sine, pi, 2 pi, right, etc., these will all give you 0. Now, when doing physics, okay, like, you know, we can live in the real world where time is just counted forward. The mathematical equation where you could have like -pi and such would be discounted. Okay, so that's kind of cool. Let's just get a little trig practice in. So I said, again, what's the speed after pi over 4 seconds? Say the velocity. Velocity, speed is just the absolute value of velocity. Velocity after pi over 4 seconds. Well, you just plug it in, right? We've already got it. It's 3 sine pi over 4. The emphasis here is that you need to know the sine of pi over 4, okay? You definitely need to know your trig, you know pretty well to do calculus. If you do enough math, you just have these things memorized, okay? It is, you know, quarter of the way up the unit circle. That is root 2 over 2, so it's 3 root 2 over 2. And I did not put units in these problems, but we can just assume meters per second for everything. So here are some basic physics and straight line applications that hopefully will be useful to you going forward.